My name is Zoran Hinic. I am the head of the lab at our headquarters in Germany at Breeden Group.
His expertise in CAD/CAM solutions in headquarters, where they provide various solutions for whatever the queries we get for the Breeden implant system all over the world. At the same time, they have developed a specific technique called Smart Connect, where you can see the presentation over here. So I am here just to convey the things in a right way. I'm just assisting him on this presentation part. So let's start. Thank you, Zoran. You can start up.
Welcome, ladies and gentlemen. We're going to talk today about a new product of the Breeden Group. It's called Smart Connect. It gives you the choice to have something fixed, screwed, and then after a time, after the patient gets maybe ill or old or whatever, maybe a new situation in his life, you as a doctor can change it into a removable frame. So this is Smart Connect. That's why we're thinking about it. It's more than just a connection, because it's some kind of lifetime bridge for a long distance. We started with the idea to think about what can we do with this smart connection, and we're sitting around, think about, like Nikola Tesla, to inviting something new in electricity. So we wanted create something new for our bio-HPP. Then we have collected our experience with 3D printing with our Formlab 2. The choice for the Formlab 2 was the only reason because this is the printer which is mostly in the labs. And since last year there is a printing material called wax castable. And we use, since then, just this material. It's some kind of resin. It's called wax castable, but it's nothing to do with wax. It's pretty hard. Even you can do try-ins with it. So we printed the primary crowns for our tie base, the Formlabs. Then you glue it with our Sky Elegance tie base, with our ComboForm UV, which is almost perfectly to connect the 3D printing material with any titanium, or if it breaks, every kinds of problems you can fix with our ComboForm UV, and to glue it, as I said. Then you have to position the fixing screw before you invest it. Also with our ComboForm UV. This is the sleeve where is the connecting, the primary connecting. Then you invest it with our invest material photo pressed. Spruing technique. We have, since March, a new kind of bio-HPP Plus. It's a little bit stronger, and the polishing you can do is much more easier and better. Then you press it with a photo press unit. And this is the result after pressing. You sandblast it. 550 microns and glass pearls, so you can use this fixing screw about 4 or 5 times. Then you ground it here with our BF2 unit and special milling tools, M8. They're developed specially for milling by hand bio-HPP, and you get such a perfect surface like here. And then after that, I grind it a little bit with our turbo grinder, and I'm working with sandpaper. I start with 400 sandpaper to get the edges and make everything smooth. And then the last part is with 800 sandpaper. And this is the result of the polishing with Acrypol. I start with Acrypol, and then the high gloss with Abrazo Star. Then I close the holes, scanning. Oh, sorry, these are the parts of Smart Connect.
So here in this concept, if you go through about this presentation or the topic, what we have taken over here, we are working all along with the CAD/CAM, as well then a log version, as well we have incorporated 3D printing also. So absolutely, this is based off friction. So somewhere you need to do a conventional techniques, and for the secondary processes, he is entering into CAD. The secondary construction will be designed and milled. And these are the respective components which are useful for this smart connect processes, and we can make sure like this is an open system. You can use these sleeves to any other implant system also to make down the strategy easier. It is not like it is just related to only Braden. Wherever there are components available as like your tie bases with respective companies, you can incorporate this strategy with other systems also.
Well, I closed the holes. I scanned it optical, no tactical, optical, because no tactical scanning for telescopic rounds is the best. But we know that not every lab has a tactical scanner, so we always try to do this just optical. And then you design your secondary frame. You open it here where the first parts of the primary crowns, and set in the secondary sleeve for the connection, which is also from titanium. Then we have a special spruing technique from our good friend Nazareno Capelli from Italy. He had some ideas about the spruing and pressing of bio-HPP. So we always use, even with such a big frame, only 2 spruing channels. And at the end of the frame, we use always a 1.5 millimeter air wind, so that the air can go out of the inside.
We can avoid the air entrapment, which is going to occur in the ring, so that as we all know, the consistency of bio-HPP when it is in a molten stage, it is just like a soft chewy. You don't find flow like your metals. So to just avoid the bubbles, we will follow the air vent strategy, where air can escape easily from the ring, and we will get a real good flow of the bio-HPP. As well, the spruing technique what we have seen in this slide, he is a master technician from Italy, Nazareno Capelli, and he is working since long time on bio-HPP. He's got specific strategies of flow behaviors. I think he's having a mass consumption of 7 kilos per year. So he always press bio-HPP, he never mills. So he was the one who is guiding us since 1.5 years to get the best flow of bio-HPP in press technique. Yesterday we have given a presentation regarding bio-HPP, where there were some values registered, like when you press bio-HPP and when you bond your composites, you have got the highest gold standard value of 40.1 megapascals. In that way, we have got some troubles in early days, like when we press bio-HPP, we are having some voids in the thickest parts of our prosthesis. Just to overcome that, he has introduced this spruing technique, where we will just incorporate only one sprue, which is made of around 4 mm, and then we follow with some air vents, and we will get the best prosthesis without any contamination or a void or a bubble. We can see it in the next slide.
Yeah, this is the result of the pressing. Almost perfect, no bubbles, nothing.
And the good point of these materials is, these materials are really supporting us well. No need to waste hours of time to finish out this. Even if we are preparing for a telescopic case like this, it's very easy to polish the inner walls of the prosthesis just with a simple polishing protocol. The main key for these cases is the pre-polishing where we are insisting a specific product called Acripol, which is based of pumice and some waxes, where you'll get a real good finish. We can have the physical touch and feel models also on Braden booth. Can just check the efficiency of the resin, what he has printed. At the same time, there are some casted elements and pressed elements. After the lecture, you can just visit the Braden booth. You can just feel how the processes have came out very well.
The next step would be also the polishing inside of the telescopic crowns.
Can just check the polish.
And this is very important. I always says again and again and again, the polishing is the most important success with BioHPP. And it has to be like polished like this. And just Acripol and Abrazo Star. And the fitting is after 15 minutes for 4 telescopic crowns. Only polishing. And now you can see the inside here. I hope you can see it. This titanium secondary part. So the fitting is titanium on titanium. Okay, next step. Here you can see the result of the pressing and after polishing, of course. And we have our setup with our key, which we have made in the beginning. Then we start with VisioLink, Comboline opaque, you sandblast it, very thin with VisioLink, very, very thin, please. Very important also.
This is a bonding system where we are entering into veneers, which are also made of composites, and those are novoline shells offered by Braden, which are industrially pressed under 250 bar pressure. So there is nothing change in between these veneers and the glass surface what you get in ceramics or zirconia. It's the same. Even in the aesthetics, there is no compromise for these. And now we have placed the veneers, done the alignment, taken a guidance key, everything dewaxed, veneers sandblasted, and the BioHPP, which was in pink, we have masked it with the opaquer, which is again a composite opaquer called Comboline, which works with catalyst. It's a dual hardening opaquer. And we have closed the access holes with a specific material called palm sleeves, polyoxymethylene. This is not going to attach with any composite or anything. It easily comes out. So it makes our workflow a bit easy. So there is no such disaster like the material has flowed down and now start digging the material. Here we can save a lot of time by choosing these type of smart options. So now the veneers have been bonded with the Comboline dentin. In our system we have two different composites. One is Comboline and another one is Creoline. The Comboline works with a catalyst which is just meant to bond, and we have 50% nanofiller ceramic particles in that, where you will get highest strength. And another one is Creoline, which is just meant for creating aesthetics. Only 10% filler ceramic fillers in that, where you will get the highest polished surface of 0.02 mu, where there is no chance of any type of accumulation onto the composite surface. So this was the cartridge of Comboline, and again the pink. There is no such compromising factor in these materials. Whatever you want, you can get. What all you need is just to concentrate a half an hour more. If you are working for 1 hour for characterization, keep a half an hour more, you will get the more precise aesthetic value, because it's a huge range of shades what we are coming forward this time. Again we have introduced 2 more shades. Now this time we have introduced paste brown, paste orange. Already we have 2 paste, one paste opaque and one paste light, and now we have introduced 2 more, and we have 5 pink composites in flow. Apart from that, 2 surface stains, 6 internal stains. So this is all more than enough to get whatever we want. If we want to get it in glass ceramics, it's really a disaster to get this. You need to work for hours and hours and hours, and it has a tendency of shrinkage. Glass always, when we layer, it shrinks. Again you add it, again it shrinks. But we don't have this type of flexibility to choose right material. Whatever we want, it is available on table. Just mix and match, play around, you can match the gingival aesthetics easily. So this was the strategy of the Smart Connect. And now people will think like whether there is an option of placing that huge or bulk abutment in India. So if we think a little more, if this is the situation, can you imagine in this way? Now it is in this way, so you are feeling a bit bulky. But if you imagine in this way, when it turns around, or you can incorporate these sleeves into the bar, your job is done. At first when I've seen this, yes, it is a very good strategy, truly interesting. But when we think about the practicality in India, rarely we could find these cases like the dimension or the possibility. But still we can choose the sleeves, we can change the situation of the case, because this is all like the mix and match of CAD/CAM as well analog technique. So we have lot of flexibility to decide ourselves, like we can go in this way. If it is not working in this way, we can change the track.
And this is all polished. Nothing is glazed. Just polishing.
Particularly in Brident, there is no such insistence of application of any nanocoat glaze or anything else. All we prefer is a 4-stage protocol which starts with a carbide and then silicon and then a pre-polisher, final polish. That's it. And to be clear, there are some more system consultants right now in this hall also who are delivering superb results, and they do have real good feedback from the clinicians. Like almost how many years, sir, you have? You have since 4 years. If the process is working well and fine, which is proving like it is good, then there is nothing wrong with a soft bite material that too. Earlier it was a fear like why we should use composites, they are not anymore definitive. But right now, even Dr. Mahendranath Reddy also has got surplus good stuff of these case follow-ups. And since 3.5 years I am seeing and I am doing, but I am sure he's got a information since around 8 or 9 years. Even on BioXS he has done this system and it's working well. This is what the final result you can get in each and every case if you have the right way of procedure.
And the place around the implants to clean.
This is the specific point. Our founder of Brident is also a dental technician, but he's a bit more than a dental technician nowadays, because he's talking about homogeneity, he's talking about compatibility. He is no more in company to decide which material has to be launched or which material has to be sold, but he is all the way into science now, traveling all around the world for different universities. And recently we have got a certification called cleanest implant of the world. Brident has got the certificate of cleanest implant, and now we are gladly introducing one more cleaning technique for the finished prosthesis, which is a 4-stage protocol, I believe. Even I am not having that particular information, but we are coming forward with most cleanliness and neat processes where you can find this spaces wherever there is an implant diameter, the abutment diameter. We will never block that. We will never block that. Up to the moment, whatever the processes we have designed, either ways in headquarters or when we came back in India, if the situations are a bit odd, if the metal is even exposing, we are not supposed to block that space. That's what they promote all the time. So in this way, of course, if it is in this case, there is no such objection even if the metal is a bit exposed. If it is onto the central incisor, which is visible, then we need to think over. But still, it's a matter of choosing abutments by the practitioner, but not by a technician. If the case is favorable, there's nothing wrong, absolutely perfect.
Formlab, and these wax castable. We printed a frame, an upper jaw. We have here a screwing, bed and screwing technique, which is very necessary if you are casting big frames, if you cast. But I think there are lots of labs that are still casting all over the world and also here. We have here a lower jaw, also with a bed and screwing technique. Then also our cast technique.
Just observe the casted result. That's the most important thing in this case.
In this case, we choose our Brevest Eco Speed because you can go in the make the speed technique with this castable wax. It's no problem at all. And I think this is the most important thing. The left side. This is the result after the casting. There had all no cracks with our investment material. Even as I told, we do it always with speed because we know this is saving time. It's very interesting for the labs. We always don't have time. Even in Germany, it has to be everything very fast, very fast.
It's the same for dental technician all over the world. All over the world.
Everywhere the same problem. Okay, maybe sometimes we have at least, when you have here 3 days for work, then we can have 2 weeks for work, but at least these 2 weeks are also not so much, but 3 days. I can suppose how hard it is to be here a dental technician in India. But I'm wondering, everything is finished. Okay. After the casting, no cracks, everything is fine, debedding, sandblasting, and this is the result. The most interesting thing at this spring technique is these what do you say for this?
The razor wires.
Yes, because you have to give the metal the chance to go into the muffle easily in every direction. So normally we have also tested, because we are making our own invest material, we are also testing casting material of different factories.
So the investment material what we have used for this procedure is Brevest EcoSpeed, and he is the person who is really in back of this strategy, like I have to prove this, I have to prove this, I have to prove this. But not only on wax resin of Formlabs, he has tried out all these materials and finally he's given information like you can do whatever you want with Brevest EcoSpeed. Really, it's a stunning result whenever I've seen the casted one. If you play around with the expansions, you will never get disappointed with this investment material. Invest your ring, wait for 15 minutes, remove the ring, dump it into the furnace, stay for 45 minutes, cast it. Cast it. There is no discrepancy. No discrepancy. If you are using a printed object, even more precise, dimensionally stable, no distortions, no drift, no walking, absolutely it will go into the position.
At least these are the materials we tested. The left side, the red one is from Shera, then the yellow one or orange one from Bego, the gray one is Formlab, the purple one also Formlab, the white one. The purple one is the only casting wax. All other resins from Formlabs are technical resins, which it also can be good. We tested at the beginning. When we bought the Formlab, we didn't have this purple wax castable. 1 year later, it has been starting for selling. At the beginning, we tried with this gray material, technical resin, and this one here, HT.
Transparent one.
Yes. And the results have been also very good. But since we have this castable material, we only use this, just this, for all indications. If I make telescopic rounds, passive fit frames for our fast and fix, or whatever, even partial denture is fitting after the printing perfectly.
And the luckiest thing is we have an additional material called Compoform. So if you print your object, if you want to check onto the model, you can place it. If you want to do some changes, you can add on this Compoform and you can start your process. It is not like you are placing your processes onto the object and now if the clasp is broken, you are not in a risk. You can manipulate things even.
Now that's the other thing we tried. We are now at print and press. Also a Form Lab. This, what I told you before, we started with gray resin.
You have this file in ExaCAD?
Yes, I have.
Can you just provide some information on ExaCAD, like how to plan or how to design this process? Not
If
now?
we have time,
Yeah.
I can later do this.
Yeah.
Okay? No problem. So we made at our headquarters a full metal model with 4 telescopic rounds. And then I scanned it, again optical. I designed a telescopic bridge. Don't be afraid because the connections are very thin. This was just to see if it's working, the technique. Then again, our spruing technique with 2 sprues, in that case 5 mm, and the air winds. The next picture, yes. It's very necessary to put on each telescopic crown at the...
It's necessary for bio-HPP,
Yes.
not for the metals.
We are now at bio-HPP.
Where they are conducting workshops. Definitely I've lost my opportunity yesterday where I couldn't finish my red and white part and I don't let you go. Surely whatever I want to do, I will do. So if people can join us over there, and of course it is a demonstration of new shades of pink with myself, with Zoran, Hinic, and another master dental technician of India, Mohit Suryavanshi, is also involving in this. If anyone wants to do something different, you people can just visit over there. You can play over these composites. We have surplus models as well the materials. Thank you.